Hey guys, so today, as your final day of looking at women in science, we're going to be focusing on Natasha Cave. So, Natasha Cave is an American mechanical engineer who's also the co founder of Opus 12, which is a startup that recycles carbon dioxide. So, looking a bit at her past and how she came to this role, her first job was as a graduate at McMurdo Station, where she serviced HVAC systems and helped build the laser diode for future NASA missions. Prior to Stanford, she worked in Antarctica as well at the McMurdo Research Station and hopes to return to the continent someday. She then returned to school to do her PhD, and here she worked on electrochemical approaches that she could use to convert CO2 and water into useful products such as plastics and household cleaners. So, to do this, she built a gas analysis system that could determine the composition of electrochemical reactions in real life. And this was for her PhD, and she obtained this PhD in 2015.
Natasha wanted to find a solution, a way to repurpose carbon dioxide waste and to make it more useful and economic. She asked the question, what if we could rewrite the story of carbon dioxide waste? And how could we reduce emissions in chemicals and fuel industries? So she had an idea to turn carbon dioxide produced by large factories into plastics, which would help reduce the amount of carbon dioxide going into the atmosphere, and thus help reduce the effects of climate change and global warming. While studying at Stanford University, she co-founded Opus 12 alongside a fellow student who was doing a business major. She then discussed the idea at TEDx Stanford, where she talked about how recycling carbon dioxide could reduce our carbon footprint and support further future space travel.
So, they had a simple idea to take electricity, the same type which we have in our homes, and electrocute CO2 from the factories and water in the presence of a metal catalyst. This breaks these compounds into smaller ones, so the CO2 and water is broken down, and it will reform new molecules. And when they did this, they realised that 16 molecules could be formed just from the CO2, water, and electricity. And these molecules, you've probably heard them before. Some examples include methane, carbon monoxide, ethanol, acetone, and 1-propanol, are just a few to name. These compounds are already produced by mass. But if they can be made by waste products such as CO2, that will be a lot more better for the environment, but also it can help reduce other human factors such as cases of cancer, because there are many abandoned factories which do leach chemicals into the atmosphere. So if the CO2 can be absorbed and used for a good reason, it can also help reduce cases of cancer caused by these chemicals, which was actually one thing which inspired Natasha Cave. However, there are some challenges, such as the finances of a startup, but another challenge is the fact that it's quite hard to find a good metal catalyst which is cost effective and reliable. And another factor was that there's lots of CO2 in the atmosphere, so you need to get a good renewable source of energy which is cheap and can cope with all the CO2. An example of that could be ones which you probably know of, for example, solar, wind, etc.
So currently they are recreating photosynthesis, but at warp speed, as plants use carbon dioxide, water, and renewable power to produce oxygen and useful carbon-based products. They wanted to investigate whether we could use renewable electricity to drive transformation just like a plant uses sunlight. So they have done experiments consisting of electrochemical reduction of carbon dioxide, which is known as reverse combustion, and it combines carbon dioxide, water, and electricity to produce higher energy carbon based products and a co product of pure oxygen. This reaction is energetically uphill, so electricity must be added to drive the reaction forward. And it's not possible without a new family of carbon dioxide reducing catalysts. So below the text, you can see this metal box, and that is a component which helps catalyze the reactions. So on the PowerPoint slide, you can see a link, which is the link to their website for the company Opus 12, which has a lot of detail about their current research and latest developments they've made in their field of study. So if you are interested in her work, then I would recommend visiting that website. Thank you for listening to our presentation about Etosha Cave, and I hope you found it interesting.